Ever feel like software standards are a secret language? Maybe one that could unlock a better tech experience if you just, understood them.
You're definitely not alone there.
Well, today we're trying to crack the code on something specific called conformance testing.
That's right. This deep dive is all about conformance testing, which you might sometimes hear called compliance testing, too. We're looking at it specifically in the software world.
And we're drawing from Software Conformance and Compliance Testing Explained. Our mission really is to get a solid handle on what this testing is, why it's actually pretty important, and how it works.
Without getting totally swamped in the technical weeds, we want the key takeaways, maybe those surprising bits.
Exactly. So let's jump in. What is conformance testing at its core?
Okay, so in essence, conformance testing is basically a way to check, to verify that a software system actually sticks to specific standards and regulations.
Like the rules set by bodies like IEEE or the W3C.
Precisely. Or ETSI for telecommunications. These groups set the guidelines, and conformance testing checks if the software, plays by those specific rules.
So it's not just general testing, it's more focused than that.
Oh, absolutely. It's very targeted. It's about rigorously checking if the system meets the individual requirements spelled out in a standard.
And what sort of things does that cover?
It looks at quite a few angles. Performance, the actual functions it's supposed to have. Robustness, like how well it handles errors.
Robustness, right.
Interoperability, so how it works with other systems and just its overall behavior. And yeah, like we said, compliance testing is often used as another name for it.
Now, for you listening, why should you care? I mean, it could sound a little abstract, maybe a bit nerdy.
It's a fair question. Why bother? Well, the source points to some really fundamental reasons. First off, it checks if the system actually delivers on its promises, its requirements.
Making sure it does what it says on the tin.
Exactly. And second, it verifies the documentation. Is it complete? Does it accurately describe how the software works?
Okay, that makes sense. You want the manual to actually match the machine.
Right. And beyond that, think of it as risk management. I mean, software that doesn't conform, that can lead to fines, damage to reputation. Sometimes it can't even be sold in certain regulated markets.
Okay, yeah, avoiding those big headaches sounds pretty crucial. So when a system is put through this testing, what exactly is being looked at?
Good question. Several things are under the microscope. The specific standards that were supposed to guide the implementation, for one.
The real book itself.
Yes. Then the system's calls or interfaces, how it talks to other parts or other software. Also, the defined scope of the specifications.
Meaning what's included and what's not.
Precisely. And the overall objectives of those specifications. What were they trying to achieve? It's about checking all those critical connection points and rules.
Got it. A deep dive into how it's meant to work according to the plan. So how does this process actually happen? What are the usual steps?
Well, the process generally mirrors a typical development lifecycle, which might feel familiar. It kicks off with analyzing the requirement specs, really digging into what the standard demands.
Understanding the rules first.
Exactly. Then you prepare a test plan, the strategy. After that, you create the specific test cases, each designed to check a particular requirement.
Like little experiments.
Sort of, yeah. And crucially, you document the test designs, what you expect to happen, how you'll run them.
Understand, plan, test, record. Seems logical.
It is. And often within these standards, you find these subsets. The source mentions profiles, levels, and modules.
Okay, what are those?
So profiles are like versions of the functionality tailored for specific user groups. Maybe a basic user profile versus a pro user profile.
Okay, different feature sets.
Yes. Levels are kind of nested. Level 1 has the basics. Level 2 includes level 1 plus more features and so on.
Like building blocks.
And modules are just collections of related standards or specs grouped together, usually by function.
Profiles, levels, modules.
Okay.
Ways to organize the requirements. Now, you mentioned conformance and compliance testing are often used together, but the source hints at a difference.
Yeah, this is a subtle but important point. While they're often swapped around, conformance testing is generally seen as the more formal and precise way of testing against a standard.
More rigorous.
Definitely. It often involves aiming for formal certification. Think about operating systems and POSEC standards. That's a classic case where formal conformance testing happens, potentially leading to an official certification.
Okay, like getting an official stamp of approval.
Exactly. Compliance testing, on the other hand, can sometimes be a bit more informal, maybe less exhaustive. It might focus on checking support for some key parts of a standard, not necessarily every single detail required for full certification.
So conformance is like, does it meet every rule for the official certificate? And compliance might be more like, does it generally follow the important rules?
That's a pretty good way to put it, yeah. Conformance often aims for that full, verifiable support.
All right. So assuming a system passes conformance testing, what are the upsides? What are the real benefits?
Oh, the benefits are significant. First, it ensures the specifications were actually implemented correctly, reducing ambiguity.
Clear rules, clear results.
Right. Second, it hugely boosts portability running the software on different systems and interoperability, making it work smoothly with other software.
Which is crucial these days. Everything's connected.
Absolutely. It also encourages the proper use of standards, confirms interfaces and functions work like they're supposed to, and really helps pinpoint where the software meets the standard and where it falls short, both in its structure, like syntax, and its meaning, its semantics.
So it works right, plays well with others, and follows the rules. Sounds essential. But the source also mentions challenges, right? It's not always straightforward.
No, definitely not. There are real hurdles. Just identifying the right class of system and the best testing method can be tricky.
Getting started is hard.
It can be. And then organizing those specifications into profiles, levels, modules, that takes careful thought. Predefining test values, designing tests for optional features or extensions. It all requires deep understanding.
Sounds like you need to know the standard inside out, not just the software.
Exactly. And the source also points out a kind of inherent limitation. Conformance testing is really good at showing non-conformance.
Finding the problems.
Yes, it tells you where it fails, but it doesn't necessarily prove exhaustive conformance in all aspects. Plus, deciding how formal the testing needs to be, navigating policies, regulations, it adds complexity.
Right, focusing on the gaps and even deciding how to look for them is a challenge. Now, let's make this concrete. The source talks about mobile systems. How does this apply to, say, our phones?
Yeah, that's a great everyday example. Once a mobile phone is basically put together, it goes through a lot of conformance testing before it gets to us.
Really?
Oh, yes. Testing is tailored to the network type, like GSM or CDMA, making sure the phone follows those specific network standards so it can actually communicate properly.
So when my phone just connects, conformance testing helped make that happen.
A big part of it, yes. They need to speak the same language. The source lists specific tests: protocol testing, safety and security, SIM card testing,
SIM card testing. Interesting.
radio frequency or RF testing, audio tests, even SAR tests for radiation levels.
Wow, okay. That's quite a list for this little device.
Mm-hmm.
What about that SIM card test?
So that's usually a two-step thing. First, validating the password or PIN for security. Second, testing the basic function. Can it make a call? And the key here is, even if the call fails, the test checks if the system correctly identifies why it failed.
So even failure gives useful data for the test.
Got it. And those protocol testing examples you mentioned, they sound like they show what's really being checked.
They do. They make it tangible. Like PT0001 tests for deadlocks. You start communication, and you expect it to just connect successfully. No hanging.
Simple enough, does it start?
Right. Then PT002 uses the ping command with the timeout. Does it get a transmit successful back in time?
Okay, basic response check. But PT003 gets more interesting. It uses ping with a count. It expects a certain number of pings and then transmits successful. But the example deliberately shows a failure.
How does it fail?
It might start pinging, but then gives a transmit failed. This flags a deeper issue, maybe a semantic or functional error. The command structure might be right, but the actual function isn't completing as expected.
So it's not just does the command exist, but does it actually do the job correctly under these conditions?
Precisely. That's where it catches subtle but important bugs. And PT004 checks state transitions. Can the phone move between different operational states, like idle, calling, data transfer, without getting stuck?
Making sure it doesn't just freeze up when switching tasks.
Exactly. These examples, even simplified, show how testing drills down into the technical standards to make sure the phone works the way the requirements say it should.
That really clarifies things. It's about ensuring your phone connects reliably, doesn't crash, handles data properly, all based on these underlying standards.
Absolutely. And for a complex device like a phone, across all its functions and network types, you could be looking at hundreds, maybe thousands of these individual test cases.
Okay, so wrapping up this deep dive, what are the main things you, our listeners, should take away about conformance testing?
I think the key things are conformance testing or compliance testing is this really formal, essential check. It verifies that software meets its specific requirements and standards.
Which is vital for quality.
Totally. It underpins things like interoperability, working with other systems, and just reliable function. And while it's related to compliance testing, conformance often implies a more rigorous, precise approach, sometimes aiming for that official certification.
It's the hidden work making our tech dependable.
Pretty much. It's critical for everything from banking apps to, well, your phone.
So here's something to think about. Given how much we rely on all these interconnected systems daily, what happens when software doesn't conform? What are those ripple effects? And maybe how could understanding these testing processes better actually lead to more reliable tech for all of us?
It's a great question. This look at conformance testing really just scratches the surface of the work that goes into making our digital world function. There's always more to uncover in software standards and testing.
CTS Academy.